Hello, you viewers, and you are most welcome to my channel Flexomaster. And here today we are going to study the chapter number 26 for flexible packaging. And this is the last chapter. We will finish in this chapter number 26. And we will start rotographic presses. Previously in the chapter we studied ink viscosity, and now here we are studying the electrostatic contribution. Why it is important in rotogravure press? Because the transfer of inks from engraved cells to web depends on the substrate ability to attract the ink and pull it from the cylinder. When the uneven surface of paper intimate contact with the ink in a cell by the substrate may not occur. As a result, the dot from the cell inks will not appear on the web. Now the electrostatic contribution ESC generates an electrical field of about 300 to 1000 volt on the backup roller at the printing nip. This field pulls inks out of the cells toward the backup roller and the web in the nip. Whether or not the substrates makes intimate contact with the ink. Solvents now considered hazardous air pollutants would lubricate inks to assist in their release from engraved cells. Their use presents such operational compliance challenges for printers that they have already been formulated out of packaging gravure inks. Without this lubricating help for releasing inks, electrostatic contribution improves print consistency even when printing on relatively smooth surfaced plastic films. Now the printing plate cylinder pressure in flexographic printing presses normally. The CI drum serves as the impression backup roller for each printing station. Ideal web tension is uniform from the start of its travel on the CI drum until it leaves to enter the overhead dryer one. Working against this ideal are the 610 nip points, that is one for each print station, as images are printed around the drum. This balance must be addressed by controlling plate impression at each print station. The constrained geometry around the drum prevents measuring web tension with standard techniques. Rather, the pressure holding the plate cylinder against the drum is set and monitored. That is the pressure from the hydraulic cylinders pushing one roll against the other represent the only control variable. Actual nip pressure is lower than the web tension, and the fluid ink on flexo plates allows the web to slip through the nip without affecting its tension. Although print quality can suffer, effects on web handling are negligible. If the plate cylinder pressure is too high, the compressible plate material will mash its image on the web. When pressure is too low, the web can wipe ink from the plates, causing streaks of color instead of carefully controlled images. Plate mounting tape and plate sleeves. These are the most important aspects in flexographic printing. Developments in this area represent the current priority for converter friendly press design improvement. The objectives are to reduce the pre-press effort and cost to prepare and mount flexoplate cylinders, to minimize the time required on press for plate cylinder cleaning and setup, and to minimize job to variability in the dynamics of plate cylinder pressure, called bounce in the industry. Traditionally, flexoplate material is mounted directly to a steel cylinders with diameter chosen to match the package impression cutoff. The process developed with elastometric rubber plates vulcanized in molds on a job-by-job basis. A given setting of plate cylinder pressures results in variable pressure at the interface of plates, with web depending on the surface area of the image and compressibility of that batch of vulcanized rubber. Although nothing can be done about differences in the surface area of the image, photopolymer plate material provides much more consistent and predictable compressibility. This consistency reduces the need of the structural reliability of steel cylinders and support use of sleeve system manufactured from lightweight composite materials. Advantages of sleeve system to flexoplate cylinder depend in large part on product mix and job sizes. The potential for improved profitability can be found in these factors. Number one, decreased setup time from hours to minutes. Number two, price competitive when compared to steel. Number three, lightweight, can be handled by one person. Number four, easy to clean and maintain. Number five, requires less storage space, allowing for a wider range of sizes in a smaller space. Plate sleeves allow repeated jobs to be mounted, stored, and ready to use on a moment's notice. Reduce plate damage by keeping plates mounted between jobs. Scribe lines on the sleeves face improve plate mounting and speed and precision. Drying technology. The CI Flexopress design has traditionally used forced air dryers, gas or electric, with centralized air heating and ductwork as required to convey air to web at desired location. This is the BC dryers and the overhead dryer. This convective drying process using a moving volume of air at a certain set of temperature to volatilize solvents from the printed inks. Two, the rate of drying depends on air temperature and the amount of undersaturated air available to hold the evaporated vapors. The temperature sensitivity of plastic films places an upper limit on the dryer air temperature dependent on the thermal properties of a specific plastic. Several approaches have been applied to the constrained DC space of the flexopresses with good results. Infrared heaters before the dryers can raise the temperature of solvents before moving air completely evaporates them and carries them off. High velocity air increase the exposure of solvents to volume of air with available vapor carrying capacity during the short BC drying residence time. The overhead dryer must thoroughly cure all of the printing inks from the first color printed at the last. In a normal convection dryer, airflow is aimed at the top of the web. The first color may well to be covered by several layers of subsequent colors, but only the top layer directly experiences the evaporative force of the airflows. As suggested, the web is supported through the dryer from its unprinted side on a series of rollers. As an alternative, flotation dryers support the web with specially designed nozzles called air bars. These provide flotation for web conveyance as well as high heat transfer coefficient. When the system is correctly designed, the converter realizes several key advantages including higher drying speeds, web stability, proper exhaust removal, and efficient energy use without the potential for leaving marks or scratches on the unprinted side of the web. These are the flexopress. This is wide web CI press, narrow web inline press, and this is mid web stack press. Now, printing inks form and chemistry. The physical form of liquid free flowing, 30% to 60% solid and 100% solid, UV or electronic beam. Relative low viscosity, closer to water than heavy syrup. Chemistry, solvent based gravure, flexographic, water based flexographic gravure, addition, UVAB, cured flexogravure. Resins. Common is nitrocellulose, cellulose, cotton linters, polyamide, rosin, crude tall oil, acrylic, petrochemical styrene and acrylic acid, phenolic, rosin gum derived, specialty acrylate used in UV, EB inks and coatings, epoxy used in UVAB inks and coatings, urethane used in solvent and UV, EB inks and coatings. Lamination. What is lamination? Film and multi-layer laminates, also known as complex film, include those flexible materials obtained by combining two or more films made up of single materials. Why are films laminated? Obtaining multi-layer structure has enabled us to increase the application of plastic materials for food packaging. Sometimes there is no single material that meets all the requirements needed to preserve the food. The combination of various materials with different properties and function therefore makes it possible to offer an optimum structure of packaging. What properties should packaging materials have? Generally, the critical properties required the plastic material used for food packaging should include the following. Number one, the capacity of provide a barrier to preserve the nutritional and organoleptic qualities of product. This means preventing gases from entering oxygen and water vapor, and also from leaking aromas, loss of carbon dioxide is carbonated beverages modified atmospheric losses. Number two, tear and puncture resistance for the material plus sealing capacity of guarantee the water tightness of the package product. All application in which the container needs to be subject to sterilization process or microwave heating should have good heat resistance. The material should have a visual appearance that can attract the consumer attention and provide the ideal support for transmitting the brand image plus information on the characteristic of the packaged product. The lamination process. The main support reel is given a continuous coating of an adhesive solution, and without coming into contact with the rollers or the other support unit, it then passes through a drying tunnel. When a forced stream or warm air and powerful extraction process eliminate the solvent, including in the coating. The only thing remaining on the support unit of the adhesive resin mixture is the solid part, which now has initial tack properties, enable it to be pressed against the other support element once it comes out of the tunnel. This initial tack prevents the joint supports from slipping and sliding. Therefore, the assembly of both these supports is wound on the reel, maintaining a certain amount of pressure between turns to ensure good contact and a strong final bond between the two. The cross-linking reaction of the adhesive progresses over time and strength of the bond increase, with at least 24 hours being required before a satisfactory bond is achieved, which enables the manufacturing process to continue, rewinding and cutting. What is solvent-less lamination used? The solvent-less system that is most commonly used. No use high performance solvent free adhesive which are guaranteed to work in most applications. This means costs are optimized and there is less impact on the environment. Solventless adhesives are developed as an industrial response aimed at reducing the environmental impact caused by evaporation of the solvent. There is some very strict legislation limiting the emission of volatile organic compound VOCs, improving the energy performance of water-based adhesive, requiring higher drying temperature in the kinks and making it impossible to offer faster speed of the production. Due to the high viscosity of these types of adhesive, it needs to be applied 70 to 100 degrees centigrade for easy machinability. Furthermore, the adhesive open time is very short, about 15 minutes. And why is solvent-based lamination used? Normally, a solvent-based adhesive is used in extreme lamination cases for post-packaging application. Due to type of treatment the product to be packaged will undergo, such as pasteurization, for example, the solvent evaporates when it passes through the drying tunnel. The reason the resins forming the adhesive are dissolved in organic solvent that might be one or more than the ethyl acetate, ethanol, isopropanol, methyl, ethyl ketone, 2-butanol. When they are to be used in the lamination machine, regardless of the solvent used in the formulation, a greater quantity needs to be added to obtain the right viscosity of the application in question. Finally, the Slitter and reminder. What is the function of Slitter and reminder? The Slitters are used to divide the mother rail into various bands. This means that from one printed and or laminated rail, we obtain further smaller rails with a specific width and customer marking ready for dispatch and insertion in the packaging machine. Finally, the mechanism used for the slitting process is often referred to a slitter machine, or a slitter rewinder. To put things simply, the main role of the slitting machine is to convert slit papers, films, and foil materials so that large rolls of these materials can be cut into narrow rolls. A slitting machine consists of three main parts: the unwind, the slitter, and the rewind. By feeding a larger roll of your chosen material through the slitter unwind, your material, when then unwound, be slit into various bits before being rewound onto coarse or various widths. This is the jumbo roll, and we'll be cutting and slit rewinding here. So we finish here. Thank you very much for your valuable time, and we complete the chapter number 26, the last chapter on flexible packaging. So friends, we have completed our chapter flexible packaging in three videos. So 24, 25, and 26 chapters. These are the three chapters on covering the flexible packaging chapter subject. And our next video will be on a different subject. So don't forget to watch and make my channel